It's my great pleasure to introduce our guest today, Dr. Pavel Duda from the South Bohemian University, Faculty of Science. It's really not a usual case that we have guests from the Department of Zoology, if I'm right, but you can see that the topic is clearly in our interests. The floor is yours.
Thank you for the introduction and thank you for having me. Yes, today I am going to talk about the past, present, and the future of human ethnolinguistic diversity. And yes, I am not a linguist, and I wouldn't call myself an anthropologist. I am an evolutionary biologist who took interest in human species and found out, like many biologists before me, that we can answer interesting questions about human evolution, behavior, and diversity in general if we apply methods that are regularly used by biologists, zoologists, such as phylogenetic comparative methods. My lecture will have two parts. In the first part, I'm going to talk about the processes that have generated present-day patterns of ethnolinguistic diversity. These are inferred using phylogenetic analyses, mainly of genetic, linguistic, anthropological, archaeological, and environmental data. In the second part of the talk, I'm going to talk about the processes which endangered this diversity today, and the methods and results are anthropological field surveys of language skills in linguistically rich areas in the tropics, in Melanesia and Africa. So the topic is big, and the problematics is very complicated, but so I have a lot of ground to cover, but I do hope that it will all come together nicely. So if you are a zoologist and you are to characterize human species, Homo sapiens, you'd say that human is an African ape that have recently expanded during the late Holocene, late Pleistocene, early to mid Holocene, all over the world, thanks largely to its capacity for cumulative culture, and have diversified and generated great cultural diversity in the process. If you was to have a humankind characterized by several dozens of ethnolinguistic groups, populations, each couple of dozens individuals from each one, and get some kind of genomic data for these populations, you could analyze human population structure, and the results of such analysis would attest to the fact that the human population, worldwide human population, is relatively young, and the differentiation would reflect our recent origin in Africa. You can apply a clustering algorithm, Bayesian or maximum likelihood based, on such data set of genomic data that characterize worldwide populations, and you can ask it to divide the humankind into a given number of clusters, ancestries, that are as genetically homogeneous as possible. So if you ask for two clusters, the answer would be the humankind is divided into people in sub-Saharan Africa and the rest of the world. In the second step, there is the division between Western Eurasia, between Africa, Western Eurasia, and the East Eurasia and the rest of the world. In the third step, another component or or cluster is discovered and that characterize the East Asia or Oceania specifically, but in this case, it's Melanesia, Papua New Guinea, because that is a very old, very ancient layer of mankind representing very old out of Africa migration. So iteratively, you can parse populations into number of clusters. This way, you can characterize ancestries of individuals. Those are these tiny bars. But you can also see this nested structure of human populations that reflect our population history. If you look at it and if you have appropriate sample of population, you will of course find out that human genetic diversity is concentrated in Africa or sub-Saharan Africa. This is, for example, what you get if you get a global data set, but African-centric data set. And you ask this Bayesian clustering algorithm to give you six population cluster for the entire mankind. You will find that they are all in Africa, but one of them, this blue one, comprised of Northern Africa, but also circum-Mediterranean region, but also the rest of the world. What is provoking and intriguing, and yeah, these are these clusters plotted onto a map of the continent that you here see like this. What is intriguing is how similar these maps look to the Greenberg classification of African languages. It becomes even more apparent if you just tweak the colors a bit. And the differences here sum up to Central African Pygmies that speak Bantu or Nilo-Saharan languages today, but genetically they belong to South African Khoisan, other hunter-gatherers. Then there is this tiny yellow bit in Tanzania. These are Hadza hunter-gatherers. But other than that, there is an interesting and surprising correspondence. Anyway, all human population genetic diversity is concentrated in Africa, and bulk of our population history took place in Africa. Like Homo sapiens existed in Africa for like 200,000 years before it successfully expanded out of Africa. So for these population genetic clusters or ancestries, there is a corresponding phylogeny or history that can be summed up to some extent by this genealogy. So yeah, long history of humankind in Africa, and non-Africans are essentially a sub-branch of Africans or northeastern Africa. And so the expansion was associated with a great loss of genetic diversity, a founder effect, and the bottleneck. And then there were following bottlenecks as people expanded across the world. First, they expanded out of Africa to Eurasia less than 100,000 years ago, and then they gradually colonize different regions, different land masses. Some were colonized relatively surprisingly early, some really quite late. But whether the continents were colonized like 10,000 years ago, like South America, or 50,000 years ago, like Australia, present-day human population is really young, and this is reflected by our genetic diversity, which is really impoverished, really low. Human species level genetic diversity is comparable to genetic diversity of large South African mammals, wildebeest, some species of antelopes, African buffaloes. Yeah, essentially, we have spread globally, but genetically, we have remained the East African large mammal that we are. When we compare ourselves to large mammals with really large geographic ranges, gray wolves, brown bears, we see much higher genetic diversity measured, for example, by right fixation coefficient. Our effective population size is also very low and have been low for much of our population history until until the mid-Holocene, but still the entire human genetic diversity and effective population size is comparable to maybe one subspecies of African chimpanzees, like Central African chimpanzee, and I would say that only mountain gorillas have lower genetic diversity than global human population. This low genetic diversity does not correspond to ethnolinguistic diversity at all. Human linguistic diversity is tremendous. You all know very well that there are approximately 7,000 mutually unintelligible languages spoken throughout the world, and this diversity is, well, if you're a zoologist, you can say that human ethnolinguistic diversity is comparable to species-level diversity of vertebrate classes. There's approximately as many mammal species as there are languages today, and language diversity is also conspicuously unevenly geographically distributed, and we see patterns that we know very well from macroecology. So there are more languages. There are more languages in the tropics, and also towards the tropics, the geographic ranges of languages get smaller. So we observe latitudinal diversity gradient and also something that we call Rappaport rule in ecology, larger language areas towards the pole in higher latitudes. Yeah, this is the distribution of mammal species superimposed on distribution of human languages, and it fits together rather nicely. More species and more languages in the tropics, and if you look at different animal groups, or for example, on diversity of vascular plant species, you see similar patterns. So this might tempt you to explain language diversity using to apply same explanations to language diversity as we apply to diversity of mammals, birds, mollusks, plants, bacteria. Problem solved. But it's not. It really is a mystery, because these species are as old as the ecosystems that they created, whereas human languages are hundreds or at the most thousands years old. Like the medium, like the length of existence of average language, at least in Indo-European language family, is up to 1,000 years. So it's all really young. Also, there are important differences in the distribution and how the diversity is patterned, because language ranges generally do not overlap, whereas species ranges do. Also, the areas covered by individual languages are much smaller. The range of one language is on average 250 times smaller than the range size of average mammal species. So there are important differences, and so it's kind of a mystery that we see such patterns. The diversity and also the taxonomic diversity of languages is also unevenly distributed. There are a few hundreds of language families across the world. The number of language families vary greatly across classification, and also a large number of isolates. But a few large language families, Niger, Congo, Austronesian, Sino-Tibetan, the three biggest comprise or account for more than 30% of global language diversity. And if you add the fourth and the fifth largest, you get approximately half of all the world languages that are concentrated in these big language families, whether most language families are small or there are many isolates. So there is this power law distribution of language diversity. Africa hosts 30% of ethnolinguistic diversity, which you might want to explain in terms of the length of how long the continent have been inhabited, but it doesn't make much sense given how quickly language diversity was generated and how old we know are families that we found in Africa today. Anyway, the distribution fits the topographic and ecoclimatic factors. We found, in general, more languages and also language families, although the conspicuously high diversity of language families is in the New World, in Americas. Whereas if you really try, like Greenberg did, you can classify all African languages into 4 large language families. I'm aware that they are highly controversial today. Most of them do not hold, but the taxonomic diversity of languages definitely is greater elsewhere than in Africa. In general, more languages are found in the tropics, on islands, and in the mountains. So most languages in the world are found on tropical islands with mountainous interior. So the island of New Guinea takes the gold medal. There is over 1,000 languages in the islands, and the vast majority of them is found in the eastern part of the island. So language diversity have been explained with the use of rules derived from macroecology, distribution of diversity of animal and plant species. So area size is one variable that played a role. Languages need space for diversification and for sustaining sufficiently large populations of speakers. Also, remoteness, the distance from a source of diversity plays a role, and geographic isolation, some barriers that ensures isolation of a population of speakers. So there is not much linguistic borrowing going on. Good barriers makes for good languages. So landscape roughness, incline, or maybe river density have been used as explanatory variables to predict language diversity. A bulk of this research have been done in the Pacific, using Austronesian languages that makes for a good study system, and the studies found that yes, indeed, the number of the local diversity of languages is predicted by island area size. Most of the islands are small. Most of them hosts only a single language. It's also a function of the distance from the linguistic homeland. Some older studies look at what is the distinction between dialects and of oceanic languages and bona fide languages, and found that the length of the voyage, like the sailing distance between islands, is a very good predictor. If it's just an overnight voyage, we would classify the languages on these islands as only dialects. If it needs more time to get from one island to the next, the resulting languages are indeed classified as languages. And then apart from these geographic and topographic variables, environmental variables were used successfully to predict local and global diversity of languages. Some people don't like to hear that something as noble as cultural diversity or language diversity should be simply explicable by something as simple as precipitation or humidity, but it's really not a new notion. Like 70 years ago, anthropologist Joseph Birdsell have noticed that languages of Australian Aborigines are more tightly packed and more diverse in the more humid areas near lakes and the riverbanks, and then their language areas get smaller and they become rarer when you go in the dry interior. Yes, so and there are newer, more sophisticated analyses that essentially says exactly that, using variables such as temperature and temperature stability, precipitation and precipitation seasonality, net primary productivity and length of a growing season, essentially the productivity of the environment, the available energy to predict the distribution of languages. The key here is that the environmental productivity mitigates ecological risks, and it allow people to become sedentary and self-sufficient and self-sufficient even in small population. Stability and predictability and rich humid environment allows language diversification and mitigates language extinction. In general, ecoclimatic factors, these factors explain bigger chunk of language diversity than geographic and topographic factors, although it's kind of difficult to disentangle them because rivers, yes, they can be seen as barriers, but they also facilitate transport, and they are water sources and food sources, and mountains are good barriers for language borrowing, or they make travel more difficult, but they also typically have very fertile soil and are amenable to agriculture and so on. So it's difficult. these analyses are also able to identify residuals of language diversity. So across the world, there are regions where you cannot predict language diversity using these environmental variables accurately. There are hotspots and cold spots of language diversity. The region with higher than expected language diversity, when you account for temperature, humidity, precipitation, stability, growing season, and so on, are first the island of New Guinea, second, West Central Africa, especially Nigeria and Cameroon, third, Central America or southern Mexico, and then Myanmar and Bangladesh, the footsteps of the Himalaya mountains. We don't exactly know what's going on there, but we know from macroecology studies that diversity sometimes begets diversity. This has been documented for the aforementioned mammal species. It might be true for languages as well. So for these reasons, we sometimes see higher than expected diversity. There are also cold spots of diversity, regions that are surprisingly diminished and then should host more languages than they do. And these are, for example, Eastern North America, especially eastern parts of the USA. Also, eastern parts of South America, Amazonian basin should have more languages than it currently has, or than it had at the time that ethnographers documented it. Eastern Australia, southern China. And here, what is a suspect is that a recent expansion in the historical time, but before the time that the diversity was documented, led to eradication of a bulk of this genetic diversity. So expansion of the English language or expansion of Han Chinese led to eradication of parts of parts of the language diversity in these areas, but we were unable to document it. We came too late. So language diversity, both measured in terms of languages and linguistic groups, language families, is peculiarly, idiosyncratically, unevenly distributed across the globes. And when it comes to theories explaining it, there are essentially theories saying that each linguistic group has its unique history, and there are like no common denominators. And then there is a infamous farming language dispersal hypothesis by Jared Diamond and Peter Bellwood. Jared Diamond and Peter Bellwood are not linguists. Jared Diamond is an ecologist, originally ornithologist, and Peter Bellwood is an archaeologist. And they came up with a theory that essentially says that the current or like pre-modern linguistic map of the world looks how it looks thanks to an invention of agriculture or multiple inventions of agriculture during the early to mid Holocene, and that these big language families I mentioned, Indo-European, Sino-Tibetan, Austronesian, Niger-Congo, Uto-Aztecan in Americas and others have spread and diversified during the past several thousands of years thanks to the invention of agriculture. This is the theory is a typical theory made by Jared Diamond. So it's a radical environmental determinism. It's a generalization, maybe overgeneralization. And you could easily Like, if you want to pick it apart, you might start by naming all the exceptions to these rules, and there are indeed many. There are, for example, several language families of primarily hunter-gatherer people who diversified rapidly and expanded across large parts of the world. For example, Pama-Nyungan languages in Australia, Athabaskan languages in North America, and so on. So you don't need to be a farmer or agriculturalist or food producer in order to be able to expand. Takže resetujeme. Jo. V pořádku, mluvím dál. A nebo nemůžete koukat do obrazovky. Okay, so far so good. So when it comes to the evidence for this farming language dispersal hypothesis, there are several lines of it. First of all, quantitative evidence. Agricultural families are on average larger, approximately 7 times larger than average language families of hunter-gatherers. If hunter-gatherer families are for some reasons large, there are no agricultural language families in their vicinity. They don't have agricultural neighbors. If agricultural language families are small, they have agricultural neighbors or neighboring language families that are agricultural and large. There is a population genetic evidence. I talked about effective population size, and there is a good indication that in the regions where agriculture was invented, there was a steep rise of effective population size in that corresponding time following the invention and expansion of agriculture. Populations expanded rapidly. And also there is something I would call an experimental or field evidence, because we currently can study some hunter-gatherer groups who were forced, for example, by governmental initiatives to settle down, to become sedentary, and to adopt agriculture. Some San people in South Africa, or Acta and Eta people, the Negritos in the Philippines, in which we observe that the things we would expect to happen. Their natality goes up, their population starts growing, and there is a corresponding rise in malnutrition, diseases, lack of leisure time, all the things that agriculture brings with it. But yeah, there are multiple lines of evidence suggesting that independent inventions of agricultures across the world might have been responsible for expansion of the selected language families that are really large and diverse today. But it's more complicated than that. Really, you could argue that yes, each and every such expansion is a unique historical event that is driven by multiple historical happenstances. So, for example, Austronesian expansion is one such tremendously successful expansion that has been driven by agriculture, rice farming, but it was not really made possible by agriculture, because the Formosan people in the Philippines today Formosan languages are not very diverse. They are disparate, but there is only like 10 of them. What made the colonization of the Indonesia, Melanesia, and remote Oceania and Madagascar possible, what was not the invention of agriculture, but the invention of seafaring and navigational technologies. Basically, the invention of outrigger canoe. And for example, Russell Gray and his colleague some time ago have documented using this phylogenetic analysis of lexical data and dating the phylogeny using archaeological data that there were expansion pulses and pauses as the Austronesians were making their way throughout the Melanesia and the Pacific, and sometimes they really needed to kind of wait for a technological breakthrough and innovation that would allow to colonize more remote areas. So technology is responsible, not agriculture per se. There are instances of agriculture that didn't lead to any expansion or diversification at all. So one of the oldest agriculture in the entire world you find in New Guinea, in the locality called Kukswam, that is now a UNESCO heritage site. There is archaeological evidence of agriculture in the very early Holocene, but these people never went anywhere. Yeah, and then when there was an actual agricultural expansion taking place in New Guinea, and it was associated with the spread of trans-New Guinea languages, what was really spreading was the culture and the sweet potato and the technology necessary to grow it. The languages were spreading, but the people were not. New Guinea remains highly genetically differentiated and diverse. So it was not demic expansion, it was just a cultural diffusion, the mechanism that was behind this. And also, it's not true that farming allows you to become independent of the environment and expand despite the environment. Quite the opposite. So another famous agricultural expansion, the Bantu expansion, that began here on the Nigeria-Cameroon border and spread to South and East Africa during like 4,000 to 5,000 years, was of course made possible initially by the invention of agriculture, and then also maybe accelerated by invention or adoption of iron metallurgy, but it was heavily influenced by the changes of vegetation cover in Africa. Because first we didn't know what was the roads that the early Bantu farmers took. Then it became clear that they took the southern road. They first went through the Congo Basin, through the rainforest, through the Central African rainforest, and they only diversified as they reached the southern end of the rainforest. And the journey through the rainforest took some 2,000 years. The farmers were spreading really slowly. And when Rebecca Grolemund and her colleagues combined phylogenetic tree of Bantu languages with paleoecological data, they found out that the languages spread through the areas where like savanna corridors were opening in the forests when the temperatures went down, when the climate changed. This was something that facilitated the expansion that was in the very beginnings really slow. So farming is not something that in general enables fast diversification and fast expansion of these populations. When if I summarize it, I would say that I can't really summarize it. You see that it's complicated. You have this overarching theory that is clearly an overgeneralization. There are many factors at play. Individual language families have complex individual histories, and the spread is always facilitated by different kinds of technology that allows for transport, whether it's saddle or it's outrigger canoe. So yeah, it's complicated. What we wanted to do was to look at the global picture and to analyze human ethnolinguistic diversification using a global phylogeny. And global human phylogeny is something that's really difficult to get because as language changes quite rapidly, it only allows you to go so deep in the past. Only some 7,000 to 8,000 years is the general agreement. So you can't really get a global phylogeny of mankind. I assume that all of you or most of you can see it on see the presentation or on your laptops. And so what we did first was that we combined all phylogenetic trees of human populations that were at the time available. We combined phylogenies based on genetic data and linguistic data, various types of genetic data that implies kind of different population history. Male chromosome, mitochondrial DNA, autosomal data, genomic data, and phylogeny is based on different types of linguistic data, so either lexical or phonological data and syntax. We essentially pile it all together. And at first, we were just kind of curious whether we will obtain a tree at all, or whether the amount of conflict will be so vast that we will end up with a large polytomy. We will lose the resolution completely. To do this, we used a method called maximum representation with parsimony. Essentially, you translate topologies of phylogenetic trees into matrices of additive binary coding, and you will collate these matrices into one large data set, and you will obtain a consensus tree, which is called a supertree. It's a consensus in which the source tree has only partially overlapping samples of taxa, in this case, human ethnolinguistic groups. And yeah, and we obtained a tree that was actually quite nice and finely resolved, as you can see. And we identified the major conflicts in human population history as implied by all these individual phylogenies. Yes, that's the one. So there are human population groups that kind of aren't, you cannot place safely on that trees, and that kind of jumps around because different types of data, genetic linguistics, imply different positions for this taxa. So, for example, Malagasy languages jumps between East Asia and Africa. Andamanese are kind of all over the place, either right outside Africa, sister group to the rest of non-Africans, or somewhere in South Asia, and so on. There are also less stable sections of this tree that are, again, it's thanks to some recent population expansions that are not consistent with the tree topology. Nevertheless, you can obtain a global tree that combines genetic and linguistic data using it. And I think the reason for a relative lack of conflict there is because genetic data and linguistic data are informative of human population history on different temporal levels. languages, like the backbone of the tree, the topology that gives you the relationship between like continents and large parts of continents are underlined by genetic data, and the fine structure of the tree, the tips, these are mainly those recent language expansions. We have expanded this tree. Originally, it was just like a methodological exercise. Then we expanded it like 10 times. So we ended up with a phylogeny of approximately 2,000 human populations, languages, approximately one third or one fourth of all mankind. We have constrained it using language classification. So these are what you would see here. Would be relationship between language families based on genes, which is interesting in its own right, but I don't want to go into it. In order to make analysis of diversification, to say something about how all these groups are and how quickly they diversified based on local factors and which families are fast and which are slow, we needed to time calibrate the tree. So we essentially, all the information that was in the source trees, we put back into this large tree based on molecular clock, archaeology, dates of colonization, historical data, old text. We did all we could to obtain dated, time-calibrated phylogeny of these human populations. And then we ran an analysis of diversification. Diversification is essentially how fast the tree branching occurs. It's counted as speciation rate minus extinction rate, although these analyses are largely agnostic of extinction rate. They assume it was very low. So it's basically an analysis of speciation rate. Yeah, also in order to do this analysis properly, we had to account for the missing diversity. So these two-thirds of ethnolinguistic groups that we do not have, we accounted for them missing on various levels. The missingness corresponds to different nodes in this tree, and yeah, it's really quite complicated, quite laborious. We run a bulk of settings for this Bayesian analysis of diversification rate in order to account for various possibilities, like how old the missing diversity is, things just inherent to the Bayesian analysis, how many, for example, shifts in diversification are possible, how fast it is changing. We essentially looked for commonalities. Now, bear in mind, this is an unpublished work and kind of riddled by methodological difficulties, because our phylogeny is a patchwork phylogeny. It's only as good as the source data are, and source data are of very varying quality. So this is reflected in the results. So they are kind of difficult to interpret. And also, yeah, I want to stick to the main message. This is the diversification. These are diversification rates in time according to different assumption of the Bayesian analysis, assumption about how quickly diversification can change and how many times and how old the missing diversity is. The common result is the diversification rate, ethnolinguistic diversification, was rather decreasing during the entire Pleistocene, and then went up during the Holocene. In the very end of the very late in human population history, around 8,000 years ago, ethnolinguistic diversification went up. If you permit for more changes in diversification rate, more rate shifts, you will get another uptick that is associated with out of Africa expansion, some 80,000 years ago. But if you permit for a few, the only thing that is important is the very end of human population history, the Holocene, and yeah, the diversification. The rise in diversification rate really corresponds to the agricultural revolution. These are so-called tip rates. This is the measured potential for diversification across these ethnolinguistic groups, and the warmer color, the faster the diversification in the recent times. Essentially, these are those tips in the tree are projected onto the map, so you see how fast different languages or ethnolinguistic groups diversifies. And yes, you see that some language families really have generated again, different results across different analysis settings. Some ethnolinguistic groups have created big diversity really fast in rather recently. The most important findings are twofold. First of all, whereas language diversity nicely correlates with latitude, there is higher diversity in lower latitudes. The relationship is really quite robust. There is no such relationship between latitude and diversification rate, because this is the relationship. There is only very weak correlation, but it's almost not worth mentioning because the relationship is strongly triangular. There are slowly diversifying ethnic groups in the higher latitudes, in the temperate, and then in the tropics, there are ethnic groups that diversify very slowly, very rapidly, or have average diversification rate. The groups in the tropics differ greatly. Tropics are the cradle and the museum of ethnolinguistic diversity. Also, the difference between farmers and hunter-gatherers, or food producers and hunter-gatherers, or foragers, you would say, is not so important, because the difference between farming groups in the rate in which they create language diversity is just so big. Some of the most slowly diversifying groups are indeed farmers, like old farming groups in Melanesia, or some groups, some isolated groups in Africa and South America. So yeah, there is a weak negative relationship between diversification rate and latitude. And the difference between farmers and hunter-gatherers, this is important, decreases with latitudes. Like, hunter-gatherers are able to generate vast language diversity also in higher latitudes. I mentioned the Nadine or Athabaskan languages, or for example, some Australian languages or languages in Tasmania. Hunter-gatherers are able to diversify only slowly, but everywhere. Whether agriculturalists can diversify very rapidly, but they are more tightly linked to their environment. This is important, and other studies has found it that ecoclimatic factors has greater effect or greater ability to predict language diversity of farmers than of hunter-gatherers. This is really important because, yeah, oh, awesome. We kind of assume, or we kind of think that that adopting agriculture or inventing agriculture allowed people to become independent of their environment. It's not really the case, because hunter-gatherers are flexible, they are resilient, they are migratory, they can move, whereas food producers, but especially agriculturalists, they are dependent upon the species, plant species and animal species they subsist on, that they cultivate, and these have their ecological needs, their ecological valencies, and farmers kind of live within that Venn diagram that is given by the ecological valencies of the domesticans. Ecoclimatic factors predict diversity of farmers better than of hunter-gatherers. Is there some trade-off between the use of the pointer and the use of the projector? Huh. Okay. It's fine, or it's going to be. Yeah. So I need to look at this at all time. Also, another important issue with language diversity of farmers, what farming does, or agriculture or food production does, is that it generates or it increases socio-political complexity, and socio-political complexity leads to range expansion. So it is possible that in the process language extinction, right? So these large language families in the temperate region, Sino-Tibetan, Indo-European, and others, as they expanded and diversified, they may have reinforced the latitudinal gradient of diversity that has always been there, but became more pronounced in the Holocene as the agriculturalists in the mid-latitudes, in the temperate, became really widespread and expanded. And so, yes, we kind of assume that the Holocene was the beginning of the language extinction that is very much going on today. That languages were really diverse up until the invention of agriculture, and then with the invention of agriculture and expansion of these farming groups, language diversity was never again as great as it was in the early Holocene. But this may really not be the case, because agriculturalists in the tropic are those that generate great language diversity, and agricultural and hunter-gatherers just aren't able to. What is the take-home point from this? What is the support for farming language dispersal hypothesis? Well, it's again complicated, because for all the hypotheses that link linguistic diversity to the environmental factors. It's complicated because the tropics and the tropical environment, so environment of high temperature, high humidity, high predictability, long growing seasons, and so on, they do not generate diversity fast, not in general, because most of human ethnolinguistic groups are found in the tropics, and in the tropics we found both very high but also very low diversification rates, and mostly low. Agriculture also does not generate language diversity really fast, because most of human population today subsists on some form of agriculture, be it extensive or intensive agriculture, and most of them did not diversify. Most language groups did not produce great linguistic diversity, or didn't expand anywhere. So in general, not. But both the tropics and the agriculture create potential for diversification, and some ethnolinguistic groups have exploited that. Like only groups, the fastest diversifying group in our analysis is Bantu or Eastern Bantu, based on how old we assume the missing diversity is. And then these are followed by Indo-Europeans, but again, only Indo-Iranian languages are really very fast, and Sino-Tibetans, and of course languages in New Guinea, although these are conspicuously old, and so on. So only agriculturalists or farmers in the tropics, or farmers that have originated in the mid-latitudes but later expanded into the lower latitudes, were able to diversify really fast and generate high language diversity really fast. At the same time, it's about about these individuals. A few highly successful language families individually have generated great diversity and only a few were lucky. So yeah, Austronesians have expanded and diversified thanks to inventing those outrigger canoes. But at the same time, it's very important that on those canoes, they were carrying with them pigs, chicken, rice, and so on, what Peter Bellwood calls the Polynesian package, that allowed them to be self-sufficient and sustainable in those very small populations. So this is what generated this great language diversity. This language diversity is under unprecedented threat currently. This is a quote from Charles Darwin from his book on the origin of species, in which he compares languages to biological species, and he described how they essentially compete for how they struggle for life, and how languages go extinct, and how languages, like species, are individual historical entities that when they disappear, they never again reappear. By the way, Darwin really liked making comparing species to languages and making these kinds of analogies. He followed work, or was familiar with the work of some 19th century linguists, William Herschel or August Schleicher, and he liked to use languages as metaphors for evolution, extinction, phylogeny, and so on. Anyway, what Darwin noted is now more pressing issue than ever. Because languages are highly endangered. If we attempt to quantify it, we found out that they are more endangered than bird and mammal species. And the current projection expects between 90% and 20% of language to go extinct by the end of the century. By the way, those more catastrophic projections are older and less accurate. So current estimates claim that approximately 1/5 of all languages will go extinct or moribund by the end of the 21st century, with the rate of extinction to be approximately some 3 to 4 languages each year nowadays. But yeah, so it's less alarming, but still really bad. Languages are endangered for the very reasons that I described previously. Most of the languages are small. So, for example, about 300 of all those 7,000 languages have geographic ranges of less than 20 kilometers, and approximately 20%, 1,050 of all languages have less than 1,000 speakers. Languages are by definition endangered where they are most numerous, in the tropics, because they are most densely packed. Having a large speaker population make you resilient to environmental fluctuation. If there is there is just a area diversity or language area relationship that keeps the diversity at bay, because languages are most endangered where they are most diverse, and small languages are susceptible to environmental fluctuations. So one example of such fluctuations may be the eruption of the Tambora volcano on the island of Sumbawa in 1815 that has eradicated the entire speaker population of the language of the same name, Tambora. And it must have been really interesting language because it was the westernmost Papuan language. It was a result of rather recent incursion of Papuan speakers into area that was at the time already colonized by Austronesians. So so we lost that to that volcano. And so if you are a language, big population, speaker population size does help. By the way, Czech is safe and sound, being among the 100 biggest and 2% of the 2% of the biggest languages in the world. To compare endangerment of languages and species is kind of difficult, but 20 years ago, William Sunderland compared the endangerment of biological species using IUCN criteria and endangerment of languages using this EGIDS scale, and found out that more languages went extinct than bird and mammal species, although across different levels of endangerment. There are more endangered languages than species, although the comparison is really difficult because language survival is not only about population size, but about the vitality of the language and how it's transmitted, how used it is. So practicality plays a role, and social prestige plays a role. And this is really the difference between endangered languages and endangered species. The death of species means death of individuals. The death of language usually means that speakers switch to other language, to English or some local lingua franca. Species have this big problem, like all those pandas and tigers and rhinoceroses just can't decide overnight that they will rather give birth to cats and dogs and horses. So languages and species are really difficult to compare. However, when we compare language and species endangerment, we find that yes, more endangered languages and species are where more languages and species are. So the correspondence is the result of the same diversity distribution. But if you compare the proportion, like what proportion of the total diversity make the endangered species make and endangered the languages make, the numbers do not fit, which indicates they do not match, which indicate that the mechanisms are really different. Ecoclimatic factors had greater effects on different slides. Higher proportion of endangered species, meaning vertebrate species, is found in densely populated areas. with higher human populations and in mountains and on islands. So population pressure really is the key factor that drives species endangerment, whereas languages, the language endangerment does not correlate with this. Higher proportion of endangered languages are found in economically developed regions. The GDP is generally a good predictor because it combines urbanization, globalization, and other factors that are responsible for language shift, like level of education. And GDP also correlates with geographic range sizes, like in areas with high GDP, languages have greater ranges, which indicates that some language extinctions have already taken place, and we are essentially late to recover them or to save them. So socioeconomic factors plays a large role. We have focused on what is going on and how important these and other factors are in the linguistically most rich areas in the world. First of all, in the island of Papua New Guinea, to which we have a good access because we have an ecological field station there in the Madang district. And yeah, the eastern part of the island, the independent country of Papua New Guinea, is extremely linguistically diverse. There are some 900 mutually unintelligible languages, accounting for some 15% of global language diversity. There were very few language extinctions so far, like 14 or 15 languages in Papua are currently classified as extinct or moribund. So compared to, for example, Australia, where language extinction was rampant, Papua New Guinea is still very well off. And the Madang district, where our station is, it's like a hotspot within the hotspot. The diversity there is really extreme. What we did, or rather what my student Alfred Kick did, was a large-scale field survey of language skills and ethnobiological knowledge in secondary school students across Papua New Guinea. This really started as Alfred, as his master thesis, and then has expanded greatly. And then Alfred continued to his PhD, and actually should submit his PhD thesis this very week. And so, yeah, so it started as the master thesis and then expanded. It was, first of all, thanks to Alfred being very hardworking, and also thanks to the fact that the schools in Papua New Guinea have collaborated with him very eagerly. It was just possible to gather all the students in the given school in some common place, like a dining hall, and make them do these tests of language skills and the ability to name body parts and bird species and plant species in the given language. So we get information about not only how well they are in expressing themselves in their native language, but also we get some notions of their traditional ethnobotanical and ethnozoological skills. So, for example, what's traditional usages of plants, of local plants, they know, like use for culinary purposes, but also sorcery and house building and traditional medicine and so on. Alfred surveyed 30 schools. In each schools, there were 17 to 124 languages spoken. So yeah, so for example, this is a secondary school in Lae. There are about 380 students there. They speak 124 languages. This is the proverbial Tower of Babel, but like the real one in the tropics. And yeah, this is Alfred giving tests to students. These are students taking those tests of language and ethnobiological skills, and these are the field forms. And this is Professor Wojciech Novotný, who is used here as the proverbial matchbox. These are results for just one school, right? So we ended up with the sample of over 6,000 students speaking 392 languages in Papua New Guinea, almost half of the local languages, and over 5% of global language diversity, which Alfred he assessed its state during his just within his master's thesis. We found out that the situation is indeed worse than we expected. 58% of students are fluent speakers of their individual language, of their indigenous languages, or they identify themselves as such, whereas 91% of their parents are able to speak indigenous language fluently. When we look at the underlying causes of the deterioration of language skills, we found that it's driven mainly by the language, whether the language is used at home. And for this, important is whether parents come from linguistically mixed marriage. Urbanization plays the larger role. So whether the students spend their childhood in the village or in town, the village remoteness and the connection to school plays a role. How they are essentially how they are able to get to their schools. Also, parents' education and their job plays a role, and the traditional skills are positively correlated with language skills, whether modern skills like the ability to use a cell phone or a laptop correlate negatively with it. There was no effect of English and math grades, and student gender also did not play a role. What was really the most important thing was whether the language is spoken at home and whether students come from linguistically mixed marriage. If it was linguistically mixed, 37% of marriages of these students are, then they usually spoke either Tok Pisin, the Neo-Melanesian pidgin, or English at home, and had poor native language skills. By the way, there is not so much linguistically mixed marriages still, although more in this population than probably in the entire Papuan population in general. But the amount or proportion of linguistically mixed friendships is very high in these schools, and if they are indicative of the future trends, the situation does indeed look very dire. Next, because we also have a field station in Cameroon where our ecologists work, we tried something similar with students in Cameroon quite recently, and we were keen to compare the drivers of language skills and ethnobiological knowledge in these two countries, because we wanted to know if the drivers are the same in Papua New Guinea as elsewhere, and also Cameroon is found within the second biggest language diversity hotspot in the world. And these two hotspots, like Papuan and West African, they account for over 25% of global language diversity. So we did a similar field survey in Cameroon using which was smaller. It wasn't done by Alfred himself, but we did get we have results for some 65 languages spoken there, and the results are curiously similar to results obtained in Papua New Guinea. Like if you look to the difference between students' skills, student language fluency, and their parents, the numbers are almost identical. They are identical across all languages, and the best sampled languages and the proportion are just same for Cameroon and for Papua New Guinea. And the drivers of language decline are again urbanization, so childhood spent in town or village, language use at home, and the modern life skills and traditional skills that are differently correlated with language proficiency. Interestingly, students in Papua New Guinea have better ethnobiological knowledge across all levels of language proficiency than students in Cameroon. Also, students in Cameroon rate themselves slightly better as language speakers. They are more optimistic about their language skills, but when we measure their ability to like name parts of the body and local species in their native languages, they were not as good as Papuans were. At the same time, the ethnobiological knowledge of Papuan students are not to be overestimated, because, for example, when we ask them to name in their native language, to name plant species and their traditional uses, sorcery, house building, medicine, food, they were, first of all, many of them were unable to do so in the native language, and they used Tokpisin. And most of them named cash crops like papaya, citrus, aloe vera, so not native species, but introduced species. So we observed a rapid loss of language skills and ethnobiological knowledge. And if we take the social economic drivers of language skill deterioration and we project it to the future, we came at a conclusion that the next generation of secondary school students in Papua New Guinea that only 26% of them will be fluent in indigenous languages. So yeah, so the loss is very rapid. Now, most students, both in Papua and Cameroon, who are fluent in their indigenous languages, want to teach their children to speak indigenous languages. And if we ask them the reasons for it, only small percent of them says that it's practical. They want to teach them the indigenous language because it's like part of their cultural heritage, and they are proud of it and consider it important. On the other hand, the drivers of the loss of language skills is what they also hold very dear, and what's important to them, and what is desired and good. The loss of language skills is associated with urbanization and modernization. So road networks, education, cash economy, mobile phones, computers, healthcare, and so on and so forth. This is something like Papua New Guinea is currently, and has not for past 30 years, experienced much urbanization. Most population is still rural dwelling. This is important, but at the same time, the march of progress, it's very difficult to stop there, and people are there has not been a great influence of, for example, post-colonialism and English language, like not really. Papua New Guinea is quite independent, and the state there is quite weak. But people are essentially dismantling the Tower of Babel there themselves. Okay, I'd like to thank to my students and my collaborators, all those who participated in this research, and thank you for your attention.